Greetings, everyone. My name is Thapello Maseko. I'm a nanomedicine ambassador at Nabai Consulting. Today, I will present about the history of nanotechnology. I will focus more on the discoveries that has been done to improve the field of nanotechnology. Human dreams and imagination often give rise to new science and technology. Nanotechnology was also born out of such dream. Nanotechnology can be defined as the manipulation of matter at nanoscale, which ranges from 1 nanometer to 100 nanometers, where unique phenomena enable novel application. The concept of a nanometer was first proposed by Richard Zygmunt, the 1925 Nobel Prize winner in chemistry. A nanometer is very small. If you can compare it to the strand of a DNA, a strand of DNA is about 2.5 nanometer wide. A red blood cell is about 7,000 nanometer wide, and a sheet of paper is about 75,000 nanometer wide. A pinhead is about 1 million nanometer wide, and a human hair is about 50,000 to 200,000 nanometer wide. A nanometer is very small. So how did Richard Zygmunt discover the nanometer scale? To answer that question, he coined the term nanometer explicitly for characterizing particle size, and he was the first to measure the size particles such as gold colloids using an ultramicroscope. The ultramicroscope. This microscope consists of a system that lights the object in a way that allows viewing of tiny particles via light scattering and not light reflection or absorption. The particles were usually suspended in a liquid, then illuminated with a strong light beam perpendicular to the optical axis of the microscope. Figure 2 is just an image that shows us how the ultramicroscopy used to look like. Modern nanotechnology. Modern nanotechnology is the brainchild of Richard Feynman, the 1965 Nobel Prize winner in physics. During the 1959 American Physical Society meeting in Caltech, he presented a lecture titled "There is Plenty of Room at the Bottom," in which he introduced the concept of manipulating matter at a nanoscale. In this lecture, Feynman made the hypothesis: why can't we make the entire 26 volume of the Encyclopedia Britannica on the head of a pin? And he described his vision of using machine to construct smaller machine and down to the molecular scale. This demonstrated the new ways of thinking, and Feynman's hypothesis has been proven correct. And for this reason, he is considered as the father of modern nanotechnology. Almost 15 years after Feynman's lecture, the Japanese scientist Norio Taniguchi was the first to use the term nanotechnology to describe semiconductor processes that occurred on an order of a nanometer. Taniguchi advocated that nanotechnology consisted of the processing, separation, consolidation, and deformation of material by one atom or by one molecule. This led to the development of two approaches for the synthesis of nanostructures. The two approaches include the top-down and the bottom-up approach. These approaches differ in quality, speed, and cost. The top-down approach. This approach is essentially the breaking down of bulk material to get nano-sized particles. This can be achieved by using advanced techniques and which have been developed and optimized by industries during recent decades. Figure 3 is an illustration of how the top-down approach takes place. We can see that the bulk is being broken down to form fragments. The fragments are being converted to nanostructures. The bottom-up approach. This approach involves the buildup of nanostructures from the bottom, atom by atom or molecule by molecule. This can be achieved by physical and chemical methods which are in the nanoscale ranges. We can see in figure 4 that atoms are being mixed together to form clusters, which are then converted to nanostructures. The golden era of nanotechnology. The golden era of nanotechnology began in the 1980s when Kroto, Smalley, Kelly discovered fluorescence, and Eric Dressler used ideas from Feynman's "There is Plenty of Room at the Bottom" and Taniguchi's term nanotechnology in his 1986 book titled Engine of Creation, The Coming Era of Nanotechnology. The science of nanotechnology was very advanced when Lijima, another Japanese scientist who developed a carbon tube, or carbon nanotube, which looked like the one on figure 5. Nanotechnology in the 21st century. The beginning of the 21st century saw an increased interest in the emerging field of nanotechnology, such as nanomedicine, nanoagriculture, and many more. This is when nanotechnology gained popularity, funders, and more people who are willing to get involved in the nanotechnology-based researches. In 2001, the National Nanotechnological Initiative of the USA was approved. In a time frame of approximately half of a century, nanotechnology has become the foundation for remarkable growth. For example, in the pharmaceutical communities of practice, nanotechnology has profound impact in medical devices such as diagnostic devices and the use of nanoparticles in the drug delivery system, in imaging tools, and the development of vaccines. And in the food and cosmetic industries, the use of nanomaterial has increased dramatically for the improvement of soil quality, which results in the high productivity level. And some of the nanoparticles are being used to develop the containers that are being used to store the food that we found in the shelf with increased shelf life. Today, nanotechnology positively impacts human life every day, thanks to all the dedicated scientists who discovered nanotechnology to improve human life. Here are my references, and thank you for listening.